So again, we need to draw a free body diagram. We have three objects, three masses, m1, m2, and this movable pulley has its mass, m. This one and this one massless. Only this one has its mass equal to m. Okay, this one downward we have a gravitational force, m1, g, upward, let's call it tension. And let's say it's moving downward with acceleration a1. Second object, m2g, here we have a tension here, tension, it means here we have a 2t. And we don't know in what direction this m2 moves, and we don't need to guess because numbers are not given. So I will assume it will move also downward. If I'm wrong, at the end we should get negative acceleration, a2. And this pulley has mass, so gravitational force downward mg, downward we have a t, here t, and here upward also t, because this is the same rope. And this pulley is moving downward with acceleration a3. Also it's moving downward again because we don't know the numbers, how many kilograms. That's why it's we cannot guess. So I'm assuming all these three objects moving downward. But in real life, in terms of physics, it's impossible. That's why we expect one of these or two of these objects will be moving upwards. So at the end, we should get some accelerations with negative value. But at the moment, there is no logic, there is no reason which one moves upward. But it's also okay. You can say that, for example, second object is moving upward. It's absolutely okay. And if it's really moving downward, you'll get negative for that one, negative value, negative acceleration. Now let's write Newton's second law for all these three objects. Let me start with object 1. We said that it's moving downward, so m1g is greater than tension. That's why m1g minus tension equal to m1a1. For second object, m2g minus 2t equal to m2a2. For the movable pulley, mg plus 2t downward minus t upward equal to ma3. So basically mg plus t equal to ma3. So we have three equations. This is a third one. So as you see, we have four unknowns: a1, a2, a3, and tension. It's obvious we need to come up with equation number 4, and this equation is should be, we believe, relationship between accelerations. Now let's draw position of the rope, position of the string at the beginning and after some time. Let me draw in this way. So this is the initial position of the rope. The length of this left side of the rope, let's call it L1, middle one L2, right one L3, and the upper one, let me call it L4. I will take in account this part, length of the rope at this here, because it will not change. There is no meaning. We can also write it, but let's leave it like this. This is at the beginning, and we know that L1, L2 plus L3 plus L4 should be constant. Rope is inextensible, so length of the rope should be constant. Now after some time, we said that all three objects moving downward, so this end of the rope, let's say it will be here, x1. This rope will be like here, and it move it for x 2. And this rope, this part, this pulley moves downward for x3, so it will be like this. This rope will be here, x3, this distance. New length of the rope at the left side, initially it was L1, and the below part moves downward. It means L1 plus x1, but upper part moves also downward for x3, so we need to subtract it. Here plus, sorry, here minus x3. Now let's come to the L2. This part was L2. This point moves downward for x2, so it means L2 plus x2, but upper part also moves downward, so we need to subtract x3. Now let's come to the L3. Initially this length was L3. This part becomes longer, yes? So basically L3 plus x2. Now let's come to the L4. This length was equal to L4. This part moves downward for x3. It means L4 plus x3. Now we should be careful. L4. At the left side we have a 0. At the right side x1. That's all. X3. 1 x3 2. This one cancels each other, so basically minus x3. Let's come to x2. x2 plus, so we have a 2 x2. It means 0 equal to a1 minus a3 plus 2a2. And this will be our last equation, equation number. So from equation number 1, a1 equal to g minus t over m1. From equation number 2, a2 equal to g minus 2t over m2. From equation number 3, a3 equal to g plus t over m. And now we will substitute into this equation number 4. And we can find tension first of all. Let's continue. Further is totally mass. A1 g minus t over m1 minus a3 g minus t over m plus 2a2 2g minus 4t over m2. So as you see here, we have a 2g, 0 equal to 2g, and minus t here 1 over m1 plus 1 over m plus 4 over m2. So from this equation, tension equal to 2g m1 m2 divided by m2 plus m1 m2 plus 4 m1 m. So this is the tension. Once we know the tension, we can come back to the equation, for example 1, equation 2, and find accelerations. Let me find only one acceleration. A1 equal to g minus t over m1. It means g minus, here m1 will be lost, so we have a 2g m2 divided by m2 m1 m2 4 m1 m. Can we simplify it further? I think yes, we can try. G m2 m1 m2 4 m1 m. Here m2. So m1 plus m2 plus 4 m1 m minus m2. This is the acceleration of the first object. In the same way, we can find acceleration of the second object. Now second acceleration, a2 equal to g minus 2t over m2. So g minus 4g m1 m2. M2 we can cancel it. Divided by so here we can see second acceleration is positive. It has only positive value because everywhere we have a plus sign. So we know that A2 second object only can move downward, but first object can move upward if this part becomes smaller than 0.